A given aerofoil section will always stall at the same angle of attack, its critical angle, but aircraft weight will affect the IAS at which this occurs. The reasons for this are explained fully elsewhere in the syllabus, but briefly, at a lower weight and a given angle of attack, the aircraft will require less speed to produce the lift needed to balance the lower weight. It's worth remembering then that the heavier the aircraft is, the higher will be its stalling speed, and that large modern jet transport aircraft may be carrying around half of their gross takeoff weight as fuel. Stalling speed will thus vary over a long flight, being considerably higher at takeoff than at landing. Surface irregularities, especially near the leading edge, have a considerable effect on the characteristics of aerofoil sections. CLmax in particular is sensitive to leading edge roughness. The revised lift curve on the screen shows the effect of a rough leading edge compared to a smooth surface. CLmax will decrease progressively with increasing roughness, because of the reduced acceleration of air over the rough section, and the consequent drop in the pressure differential. Roughness further aft of about 20% chord will have little effect on CLmax or the lift curve slope. Frost, snow and even rainwater can significantly increase roughness. Dirt or slush picked up from contaminated parking areas, taxiways and runways will also have a serious effect. In-flight airframe icing will accumulate on leading edges and can also disrupt the airflow and reduce CLmax. Depending on the type of ice and the rate of accretion, airframe icing can cause a serious loss of lift and a drop in CLmax. One of the most potentially dangerous consequences of such a situation is an unknown increase in stalling speed. When we compare the lift curve of a clean wing, that is, with all high lift devices up, with that of the same wing with flaps down, it can be seen that the lift curve moves up and to the left. This has the effect of increasing CLmax and slightly reducing the critical angle and the angle of attack for any given lift coefficient. The benefit of the increased CLmax is to reduce minimum flight speed or stall speed, VS, and thus allow lower speeds and shorter field lengths for takeoff and landing. The lift that a wing produces will vary greatly under different conditions of weight, surface contamination, and configuration. The appropriate lift curves can provide useful information about an aircraft's performance.